Hello and welcome to our lesson on radicals to exponential form with variables, a more advanced look. First, let's talk some definitions. A radical is an expression, so no equal sign, that includes a number or a variable, or it could be both, a radical or root sign, and an index. So your index is the teeny tiny number. There's your coefficient, your variable, and your exponent. Those are all the radicands. And then you've got your radical symbol. A radical term can be written in exponential form. This is when the numbers and the variables become the base, and the base is the big number, and the index becomes part of the exponent, and it's usually in fraction form. So I had my base of 64 in x, and then I've got little teeny tiny fractions, and we'll talk about those fractions in just a minute. Let's talk about how to convert them. The radicand becomes the base, which is the big number, so the 64 and the x are both going to be the base. The index of 2 is going to become our denominator for the new exponent. The current exponent for the radicand, which is a 3, and also the invisible 1 there, become the numerator for the new exponent, and the radical sign disappears and becomes the division sign. Look, here's our radicand of 64 and x with the cubed. 64 and x are our bases. They're still going to be the bases, the big numbers down here. Our exponent of 3 moves to numerator position, but notice the 3 is only attached to the x. It's not attached to the 64. We have an exponent of 1, which is now our numerator. And the index of 2 becomes the denominator on both of them. Please keep in mind that the exponent is only attached to the variable of x for this 3 right there. It's being cubed, but not the coefficient of 64. The 64 has its own exponent, and it's an invisible 1. See right here? That's why it did that. That exponent of visible 1 stays as the numerator. The exponent that was written of 3 is only attached to the x and not to the 64. Let's try some examples ourselves. We've got 108. That's the new base. And x is also a base as well. 4 for an exponent becomes the numerator on your x. However, we have an exponent here that's invisible, and it's 1, so that's our numerator. There is no index written, so it's assumed to be 2, and the index always becomes the denominator. But if you notice, 4 over 2 can be reduced. So your final answer would be 108 to the 1/2 x squared, because 4 divided by 2 is 2. So this is the exponential form for the radical. Now let's look over here. I've got a numerator and a denominator. We're going to have to keep them as fractions when we transfer them over to exponential form. So looking at the 3y squared, you've got 3, which is a base, and you've also got y, which is another base. You do have an exponent of 2, becomes the numerator for the y. There's no exponent here, so we assume it to be 1. That's the numerator for the 3. There is a written index this time. It's 4, so that becomes your denominator. Now that took care of the numerator on the actual radical. Let's look at the denominator. You've got 54 to the 3rd. We have a numerator this time. It's 3, and it's attached to the 54 only. For the y, there is no exponent, so we're assuming it to be 1. So that becomes the numerator. And we've still got that index of 4, so that is over 4, both of them. You do have one thing that you can reduce. Notice right here, we can reduce that. 2 over 4 is actually 1/2. So we're going to change that. 3 to the 1/4, y to the 1/2, just reducing that, over 54 to the 3/4, and y to the 1/4. This now is the exponential form of the original radical. Let's try 2 more. Just because you have a decimal doesn't change anything. You can still write it as a base. There's no exponent, so we assume it to be 1. Then you've got your other base of z. There is an exponent. It's 8, so it becomes your numerator. We do have an index of 5, so we put both of the numerators on top of the denominator of 5. You can't reduce any of the fractions, so we are done. This is now your new exponential form of the radical. Last one, we're looking at another fraction. which means we're going to leave it as a fraction in our answer. So we start with the top. 64 does not have an exponent. It's assumed to be 1. And then we've got m to the 10th. There is an exponent, so we write it as the numerator. We've got square roots, so they're going over 2. They become your denominators. That's for the numerator portion under the radical sign. Now we're going to look at the denominator portion. We've got a 16. No exponent there, so it's assumed to be a 1. That's our numerator. And then we've got m to the 4th, and it does have an exponent, so that becomes the numerator here. Same index of 2, so both of these are written on top of the 2. All right. We've got 2 that we can reduce. The m's, m 10 over 2 and m 4 over 2, those can be reduced. And we're going to end up with 64 to the 1/2. And then we've got m, 10 divided by 2 is 5, all over 16 to the 1/2, that's already reduced. And then m, 4 divided by 2 is 2. And one more thing, we've got this negative sign out here, so we have to have it in our answer as well. This right here would be our exponential version of that radical sign. For a quick review, the radicand becomes the new base, the big number, the b. The index, that tiny number, becomes the denominator of your new exponential fraction. So the I goes on the bottom. Right there. The original exponent that's attached to the radicand becomes the numerator of the new exponent. So you're going to put the original exponent goes up on top as numerator. And then that radical sign that was there changes to a division sign for the new exponent. So BEI. And that's it for our lesson on radicals to exponential form with variables, a more advanced look.